What's up, guys? Today we're going to do the problem called container with most water, which is Leetcode problem 11. So let's get started with the problem. So the problem is you are given an integer height of length n, where each element of the array is basically the height of a wall or a pillar, and you have to find the maximum area contained in any two pillars. So, for example, let's see an array. Uh, so this is an array, which is an example array in the question. So it basically represents heights in the xy axis, right? So the first one is 8, first is 1, second is 8, third is 6, fourth is 2, fifth is 5, sixth is 4, seventh is 8, 3, 7, something like that. So we have to find the two containers which contain the maximum water, and we have to just return the maximum amount of water which is containing any two pillars or container formed by any two pillars. So this is the water that contains in these two pillars, as you can see, because the shortest pillar determines how much water is in that pillar, and any extra water gets spilled out of the shorter pillar. So this is the water, and if you see the formula, it will be minimum of the heights of the two pillar multiplied by the distance between the pillars, because the container is formed with the x-axis. So this length, which is basically let's call it x2 and x1. So the length will be x2 minus x1, right? So this is the formula of the area of water contained with any two pillars of height 1 and height 2. And similarly, we have to find all the pillars and find the maximum water. So how do we solve this problem? Let's go on the solution, right? So provided we have any number of pillars, you can see that the first solution is pretty simple, right? We can go through all two for loops and compare every pillar with every other pillar and try to find the solution, right? So which is order of n square basically. So if we in one loop we take one pillar, and in the other loop we take the rest pillars and solve for all the solutions, it is n square. But is that the most efficient that we can do? Because n square is pretty maximum complexity. So is there a way to do it better? I think there is. So if we really look carefully in this example, so the height of the, if we start from the very far apart pillars, right? So the length of the distance between these two pillars determine basically the water that is contained in between these two pillars. So if you really think about it, right? Pillar P1, P2, right? Let's say if let's say two pillars P1, P2, and the water is X. So the lowest pillar determines the area of water, right? If you see the formula, it's the minimum of the height into the distance between them. So if you, let's say, move the higher pillar, if you keep the lower pillar constant and move the higher pillar towards the lower pillar, no matter how much bigger height you find the pillar, the water will always be less than or equals to x. It will always be less than x because the length is decreasing between P1 and P2, right? But if you keep the P2 constant and if you move P1, then there is a possibility that you will find a larger pillar, and the distance will still decrease between two pillars, but there is a chance that the minimum of those two heights will increase because P2 is definitely larger, and if the next pillar is even larger, then the height will definitely increase. And in that case, there is a possibility that you will find a bigger container basically which holds more water, right? So yeah, that we will use this thought process or this analysis to write a more efficient solution, which we can do in order of n times. So yeah, let's jump to the solution. So I've already written the solution. As we described, we will start with the farthest apart pillars, left and right, and we will hold the amount of water in this variable. So we will have this is the maximum amount of water, and then we will have a while loop which runs until the left is not equals to right, and this is nothing but we are just checking if the we already encounter bigger max, or this is the area of the water with the current two pillars that we have, or the current two heights, which is right minus left, which is the distance between them, and the minimum. So we were determining like which pillar to move based on like which one is smaller, and then we at the end we just return the maximum value, and this will work. So you can check for yourself whether this solution works, but this is the idea to solve this question. Thanks.